Hey everybody, welcome to the channel. Today we're going to work on a piece of test equipment. It's very useful for home electronics repair, especially vintage amplifiers and radios, and that's a dim bulb tester. Basically, a dim bulb tester can be used in place of a fuse. If you want to test a piece of equipment, probably the best thing to do is to have a properly sized fuse protecting the piece of equipment. But in lieu of that, one thing you can do is use a dim bulb tester. And today I'm going to go through the schematic and show how to build one. I'm going to build one and we can test it out, and I can show you a little bit of the theory behind how it works. Okay, here are our basic components that we're going to use. I've got several single or dual gang boxes. I'm going to use steel ones. You don't have to use steel ones. And then I've got this outlet that is for this light fixture. And then I have an incandescent bulb. I'm going to start with, this one's a 60 watt. So you have to use incandescent bulbs. You can't use LED bulbs. They will not work. Then I also have an on-off switch for it, and then an outlet to plug into, for me to plug into the radio that I'm going to test. And then I also have wire. I've got green, white, and black wire. And I also have a 3-prong plug, which I highly recommend. So you want to use a 3-prong plug, especially if you're using metal boxes, because you want to have your metal boxes connected to ground. Okay, here's our circuit for the dim bulb tester. So we start off with, this is our plug. I showed you the black wall plug cord that I have. It has 3 prongs on it. Hot will be associated with black, neutral will be associated with white, and then you have your ground, and that will be green. So here's your plug. Sorry, this got kind of messy when I had to add the ground in. So this is your switch to turn everything on and off, and the black wire goes through the switch and continues on to the light bulb. This box right here is the metal boxes that I showed. So light switch will go in this one, and there will be a ground connected to this metal box. Okay. Then we come over here, we have our incandescent light bulb, and that's in a socket here. And then that will also be in a box, and there will be a ground going to that box as well. So, and then the black continues, the black goes through the light bulb, and then it goes to the outlet. It goes to the hot side of the outlet. Okay, so these two are connected together internally. So you can use either one of these outlets. I guess I can draw that. So this is basically like this internally, and like this internally. And this is your hot right here. This is your black, obviously, and then the white is your neutral. Okay, and then again the ground continues and it connects to the steel box, and your white goes around and connects to the other side of this outlet, and you can see the white, or the neutral, goes straight through. Basically it doesn't connect to anything. So I'll draw a simplified version of this without all this stuff in here so you can kind of see what's going on. I'll do that a little bit later in the video, and you'll be able to see without all this hardware kind of how it will work. Okay, and the last piece under this is, with this outlet you can use one of these 2 outlets, and you don't use both, you only use one. You only test one piece of equipment at a time. Your test unit is a radio, or you can use it on modern amplifiers and things like that. And the only thing you do is you just adjust the wattage of your bulb that you have installed. So I've seen some pretty fancy setups that people have done of a dim bulb tester with, you know, ammeters and extra switches. You can actually do a box where you have multiple light bulbs in series, and you switch them in and out instead of having to unplug or unscrew the bulb each time. But I'll go through the bulb sizing as well as part of this video. Okay, here's my setup. So the parts, this is a board. I guess you can see that in there. So I'm going to mount all this stuff to a board. I may actually cut this board down just a little bit, make it smaller. And my plan is to put some loops on the sides so I can hang this on the wall if I want to. So a lot of people, you know, you're limited on your space. So I guess one thing you can even do that I've seen in some pictures is you just connect all these things together, connect all these boxes together and put your cord in there. And this is your dim bulb. You don't have a board or anything. It's just a box. Or you can use a 4-gang outlet. You know, it's just one of these boxes in one. It doesn't have, it's not 2 boxes, it's 1 box. So you could do that as well. There's a lot of ways to do it for your needs and for your space needs. The parts that I have are actually unused. The switches I don't know about, and the light bulb socket I don't know about. Although all this stuff looks unused. I found this at a secondhand, or not secondhand, but we have a chain in Iowa called Restore where people can donate unused electric components and plumbing and lights and things like that, and it gets resold, and the money helps the Habitat for Humanity project here in Cedar Rapids. So they have money to use for their house building efforts. They may use the money for other things as well, I'm not sure, but you can see I only paid $1 for this light socket. These other things, I think these might have been 25 cents a piece for these switches. I don't remember. And then the boxes, these might have been 50 cents. They're not marked. You just go up to the cash register and they ring everything up for you. So I think I spent less than $5 for this collection of stuff right here. My 3-prong cord is from a toaster oven that my mom gave me that was end of life. So I just cut that off there. And then this wire is just wire I had bought from other projects, for other projects. So, all right, we can get building here. All right, so this is what I came up with. So I'm going to go through the switch. My outlet, my power cord is going to come in through the bottom here, and then it will go through the bulb, then back out to the outlet. So that's just the way I decided to do it. You can do it however you want. So these boxes were never used before, so I need to punch out the connectors. So I'm going to have those 2, and then I need to have 1. So these don't quite line up, so I'm going to, but it's close enough. So I'll just use the top one on this one. And as you can see, these haven't been used. These boxes have never been used, so somebody must have bought them for a job and they just never ended up using them. All right, so I'm coming in bottom here, my switch. I'm going out to the light bulb, and I'm coming back in to the outlet. So I need to punch this guy out too. All right, so I'm going to pull these plugs up out of here. A real electrician would know a fast way to do this, but I'm not a real electrician, so got to come up with my own way of doing it. I also realized that I don't have any I can't remember what the name of them are. There's wire connectors or wire plugs you're supposed to use on here to protect your wire, but I don't have any of those, so I'm not going to use any. I'll just put a little bit extra tape around the wire that goes through there, the wires I should say, but I'm not gonna spend money on those. This isn't going to be moving. It's once I have the wires in there, the wires aren't going to move around. The only ones that will move around is the one going into the switch. I will take a little bit of extra care with that one and make sure that where this wire comes in, that has some protection so that it won't get shorted out or won't get chafed real bad. So here's my 3-wire conductor. This is just a jacket. This isn't part of it. And then I was going to strip these back a little bit. I'm going to have to see, I don't know if this jacket goes through. Yeah, so that jacket, I don't have a good way to tell these are different, so I'll have to ohm it out with a ohm meter so I know which is which. So what I'm going to do first is I'm going to run the wires through here and figure out where I need to cut them and make connections. So this, I got to do my punch out for that one yet, but this is going to go through like this. The ground is going to get grounded on here, and then I'm going to take another ground wire up to this box and over to this box, and then this one of these is going to go to my switch, and then I'm going to have another black wire that goes through here to my dim bulb, and then I'm going to have another black wire that goes through the outlet. But the white wire is going to go all the way through. So the white wire, actually the white wire I think I can just, yeah. So the white wire I can just run through this right here. I don't have to run it all the way through there. And it's going to go to this side of my outlet, I think. Yeah, so, okay, yeah. So the hot one is going to go to the brass, and then the neutral is going to go to the shiny one. So that's how that's going to go. Alright, so I'm getting an idea of how I want to lay this out. So you can see the switch right here. So I'm going to cut this off. So I figured out that the one on the right side is, I have this upside down, but the prong on the right side when you're looking at the end of the plug is the hot. So the one on the right side of here is the hot one. So what I did is I marked the white one. This is typically what I do. If you got wires, you don't know what's what, I'll mark the white one because I got white marker pens, and I got black marker pens too, but you can't see it. So I use a white marker pen. So I'm going to cut this off, and I think I might have lugs that I can use. So I'll get some lugs, and that'll make it a little bit easier because this wire is stranded, and usually you would use solid wire. And I don't have, usually line cords are stranded wire, so it's not your typical way of doing wiring. That'll work. once I have that figured out where that's going to go, so this will go like this. This will come in here and connect here. So what I'm going to do, I'm going to wrap this in tape and shrink tape it, and that'll give a little bit of protection to this wire so that it's not getting cut by this, the edge of here. Before I go too far on this, I'm going to screw down my outlet boxes. The reason being, you can see this porcelain sticks out a little bit, so I want to make sure I leave myself space. I have cover plates too, I kind of forgot about. So I need to make sure I get all this stuff so that there's space for them to get lined up. So I got that. All right. And then I'm going to look again to make sure my holes line up, and I got my holes line up fairly decent. So I'm going to check this one more time. So those screws go in like right there, and that's about just like that. All right, so that's pretty good. Actually, I'm gonna move this guy up a little bit because I want the holes to line up better. All right, so right like that. I'm probably not going to screw down all these, put screws in all these holes, but I want to make sure I'm lined up. I guess I can do the same thing with this guy. And then I just have a variety of screws in my screw pile that I'm going to use. And then this is the heat shrink job I did. So I wrapped this with some tape first, just electrical tape. And then I got the shrink tubing on there to protect it just a little bit more. And then what I'll likely do is put something inside here, maybe a zip tie or something to keep this from pulling out so that there's not stress on it. All right, so I got a good chunk of this wired up. The grounds probably are not, the earth grounds are probably not being done the right way, but that's what I'm going to do. I am grounding the boxes like I'm supposed to, and this is a really conventional circuit anyway, so I don't know why I could be faulted too much for that. One change I made, on the diagram I showed that this was going to be black. I was going to make this side black, but this side I'm actually going to make neutral because I want to have the outlet plug in like that instead of being flipped upside down. So the only difference is the black. So the black is still going to go through the switch, but it's going to come over to this side instead of this side. So otherwise it's exactly the same. So I would record more of wiring this, but it's kind of boring, and I don't know if there's that much to see. I'll go through it again when I'm pretty much done with it and before I put the lids on. All right, I'm buttoning up the outlet. I'm happy with how that looks, and I've got all the grounds taken care of, all the earth grounds, and the for both the box and for the outlet itself. There's a ground lug on the outlet, and you have to put a connection to that as well. And all the grounds connect together, all the earth grounds connect together. So they all go to the same place. So next I'm going to connect up my the rest of my outlet, or my light bulb. So this is going to go right through here and right back out again to the switch. And I think that is that's the last connection I need to make, besides this ground to this box and the ground to that outlet. So I'm ready to button up this guy. This is the light bulb. I got, it goes in, goes out, and it goes to the outlet. And I've got those connections all made already. This is a handy use of, if you got little pieces of wire laying around from other projects. I always keep those instead of throwing them out. So I had, other little pieces of wire that I could use. I got my spools, of course, but I didn't even have to use anything off of there. And here's another piece of wire left over from another project that I did. And, maybe there's 2-3 feet of wire there. And, just keep that stuff around in case you need it. All right, so the power cord, as I mentioned, coming in this is stranded wire in this cable, which is kind of what you would expect, because if it was solid wire, if you had 3 pieces of solid wire, this stuff does not bend easily, so it wouldn't make sense to make a power cord out of solid wire. But internal to the box, I'm using solid wire for everything, because that's what's used for utility, for electrical wiring. You always use solid wire inside boxes like this to connect to the terminals. So this one right here was stranded wire, so I decided to put a crimp on there and put that under that screw. So that was the reason for that. All right, I got this pretty much put back together. One thing I was going to show you guys, you can't really see it in here anymore, but all my grounds are terminated together. I used one of these Wago connectors. If anybody's ever used these before, basically, so it's got 5 positions in it. You put your wire in here, you push down and it holds your wire in there. And this is all common, so you can connect everything together. So I had 4 grounds in here all together, one for the switch, one coming in from the rest of the circuit for the earth ground. Then I had this box as an earth ground, and then I had a ground going to this switch, the side of the switch. So that's all ready to go. I'm going to put the lids on these, and then we'll go through some testing. Yeah, I'm gonna have to move this guy a little bit. Shoot! All right, so I have this all finished up, and I've got it plugged in, and I was gonna do a little bit of a demo here to show a little bit what's going on. So this is powered off right now. So if I go in here and here, I should get nothing. Let's see if I can do this. These have child safety things in them. There we go. Okay, so I got essentially 0 volts. If I plug this in, I expect to get 120 volts across this outlet. So this is basically, and then if I take this light bulb out, the 120 volts goes away. So this is a series. The hot is, or the line, I'm sorry, the line voltage goes all the way through. So if I measure across here, my potential is 120 volts. So obviously if I'm testing something, I'll plug it in here and it will see 120 volts, right? And depending on the amount of current whatever's plugged in here has, this light bulb is going to glow bright or dim. And we'll do an example of that here in a second. All right, this is a Philco radio that I redid probably 15 years ago. The only thing really wrong with it was the power control was broken on it. The volume pot was completely worn out, so no sound came out of it. I did replace all the caps because they looked really bad. It had all the wax capacitors in it, which is kind of what you expect for something of that age. It appeared no one had ever done any work to it. I don't remember finding any caps in there that were not original to the radio. So one thing I was able to find here is some bulb sizing information. So for a small radio, which I would qualify this as a small radio, it says 15 to 25 watt bulb. I think I have, I have a 40 watt bulb here, and I have this little appliance bulb, which I don't see a marking on it. It's probably 15 to 25, so that's what I'm going to start with here. So I'm going to turn this off. Put in the bulb. Plug this in and turn it on. All right, I'll turn this on and then I'll turn this on. Actually, you know what? Turn this on first. Turn this on. That way I have the power to turn this. So I expected it to glow bright and then go out. It didn't do that. All right, let's see what's going on here. Try this again here. Maybe that bulb's bad. It's a 40 watt. I'm going to turn off the overhead light, so if anything happens, we'll see it. Okay, and the bulb is going out for the most part. So I don't get many stations because I'm in a basement and I don't have well, I have the internal antenna hooked up to this.
But I think we're getting closer. This is the Simon Coleman Show.
All right, so this is a working radio, as you can tell. So we didn't have any surprises here. So what this is doing is when I first turn it on, there's an inrush of current because this radio will draw a little bit of current first to start with before it gets warmed up. And what happens is the bulb lights up because there's a lot of current going through there, and the bulb itself absorbs the power because this is a 40-watt bulb. So this bulb is going to absorb some percentage of 40 watts. If this is directly shorted, this will absorb quite a bit of the current. But what you want to do, I've got something else I'll plug in here that I haven't plugged in before. I've got a couple things maybe I'll do. But if we see this stay bright, then we know that this is shorted internally. So if this stays bright the whole time and doesn't become dim, that means something is shorted inside your unit under test, and you need to turn it off. You don't want to keep it going the whole time. The other thing on this is, if you don't want to go to the trouble of making a dim bulb, you can use a fuse instead. So for something small like this, you'd maybe use a half a watt slow blow, or I'm sorry, half an amp slow blow or an amp slow blow. So a slow blow fuse will allow inrush current to go through, whereas like a car fuse, usually, like if you have a 5 amp fuse, as soon as it sees 5 amps, it's going to blow. Whereas a slow blow, if it sees, if you had a 5 amp slow blow, it might see 5 amps, and if it sees 5 amps for more than a couple seconds or something like that, then it will blow. But it won't immediately blow just like that. It actually will last a little while. Okay, here's another device we can test. I bought this off eBay. I don't know anything about it, other than I take that back. I know something about it. It's called it's a Montgomery Ward's Airliner radio. It's a tube radio. It is a portable radio. It used 2 pretty big batteries to power it. They aren't really super practical because, I mean, the batteries just don't last very long because this has tubes in it. So this has a switch for AC, DC on the front. Okay, I got it in one position. I don't know if that's AC or DC, but if it's DC, it probably should do nothing. If it's AC, it should work. So it's not doing anything. Try this again. Still not doing anything. Actually, I guess this turns it on and off too. I didn't catch that. Okay. Okay, that's not doing anything. So I haven't plugged this in. Like I said, I haven't done anything with it, so it may have something else going on. I've got a couple other things we could plug in and see what they do. So let's do that. All right, here's another piece. I bought a pile of stuff a guy was selling, just random things, and most of them he said don't work. This is one of them I got from him, and I don't know anything about them, so I don't know what it will do, if anything. This may have a fast on thing, so if I turn this on, it might do something. So far it's not doing anything. Okay. So it sounds like it's got a relay that's trying to come on, and perhaps it's got an overcurrent in it, and that's why it won't turn on. Yeah, so that, you know, like I said, this has something wrong with it. I don't know what it is, but I'm guessing this is overcurrent. This is overcurrent, and when it gets enough current, it shuts itself off. So that's why the light bulb, you know, it gets bright and then it turns off. So when it's the peak of brightness, this is saying, nope, too much current, and then it's shutting off. So I'm just taking a guess that that's what it's doing. But that's why you would use something like this, is to protect your equipment, so that if something like this happens, it'll, you know, you have a chance before it blows up to do something about it. All right, here's the circuit one last time. Thank you for watching. I hope you subscribe, and I hope you like the content. Tell others about it if you want. So one last thing I was going to go through here is kind of a summary of this. We kind of already talked about it, but so here's your AC coming in. You got a light bulb. Drawn upside down this time. You got a switch. I guess the switch is over here. Then you have your outlet. And you go back over here to AC. So as you can see, this is really very, very simple. And one thing I was going to show you that you could do an alternate wiring is, you know, the switch in here still. The outlet, I guess, is wired the same. You put a fuse in there. You don't need all this if you use a fuse. Fuses cost money. They're like 70 cents a piece or something like that. If you don't want to take the time to make a dim bulb, you don't have to. Just use a fuse. Your unit may already have a fuse in it, but then you have to chase down, if the fuse pops, you have to chase down what's going on. Thanks, everybody.